All right. Hi, everybody. Seeing people trickle in, it is awesome to see you all. We're going to be getting started in a few minutes. I just want to make sure that we have everybody who wants to be here here in place.
Hi, everybody. Thanks for tuning in.
Ciao.
All right. I think we're good to get started. So welcome everybody to the Open Lakehouse and AI webinar. I am really excited to be welcoming two incredibly smart, incredibly forward-thinking gentlemen here today to be presenting with us. And today we're going to be talking about a really exciting topic. Specifically, we're looking at functions to AI agents and how we're reimagining the Lakehouse for an agentic future. And this is really exciting space thinking about the way that Lakehouse is being redesigned to interface with machines and agents, and all of these really good things that we'll get into in a little bit. So there's a lot of really cool innovations in this space right now, especially in the catalog space, in the governance space, in the metadata space. But a lot of this still is missing a really key piece, which is the ops, right? And so really, how are we managing agents? How are we managing these interfaces? How are we scaling these sort of different processes? And what sort of fine-grained access controls are we able to implement there? And really, how do we measure a lot of the performance of these agents that we're building? Right now, coming off of OpenAI's Developer Day, there's been a lot of things that are really at the top of mind for a lot of folks. And today we're going to have two amazing speakers come and talk about this with us. So the first one is going to be Ciro Greco, who is the founder and CEO of Bauplan, which is a serverless computing platform for complex data workloads. And so using this platform, developers can write complex multi-language data pipelines with zero environment management and infrastructure configuration. And this helps create a feedback loop for your code really instantaneously. It helps you scale your business. It also helps you scale your code, especially when you're working with AI. Formerly, he was the founder of Tuso, one of the NLP startups based in SF, and which was then acquired. So he's got a bit of time in this space, which is awesome. And then joining him is Jacopo Tagliabue, who is also the co-founder and CTO of Bauplan. He comes from many different places around the globe, specifically at UniSR, SFI, and MIT, which is an awesome resume to have. And he was also the co-founder and CTO of Tuso as well. So these two have a little bit of a history together, which is awesome to see, which was also acquired. And then eventually they started to make this new business that they'll be talking about today in terms of the open source space and technologies and how it's revolutionizing things. So really excited. I'm going to let you two take it over and introduce yourselves. If anybody in the audience has questions, please do use the chat Q&A button to be able to input your questions. We're going to be really interactive today for this session. And my name is Lisa. I'm from Databricks, and I'm going to be helping host today. Thank you so much.
Well, thank you very much for having us. This is great. Thank you. I think like when we wanted to start today is kind of like in talking a little bit about what is the relationship between AI and data these days, as it seems that that relationship has been like very historically like tied to bringing data into AI and making like AI more performant. And now is the first time where we see the possibility of kind of like going also on the other, like in the other way around and having like AI systems actually helping people interact with the data, which is something that we're very interested in and we're working like very thoroughly on these days at Bauplan. So just like very high level, the point that we're going to make is essentially that AI agents will be accelerating exponentially your access to data, and that we should kind of uh, build towards a world where humans and AI agents will be working a lot on data together. And the questions that this raises is, so many, like from security to authorization, but also like more deeply into the data space, as in like what is a data platform that is designed for this future? Like how is data, like how should we think about data systems when they're not only built for people, but they're built by for AI systems. And one of the most important problems that we think right now is creating a lot of friction in the adoption of this is actually the problem of solving trust and security. So I think like generally speaking, like we're kind of like all in agreement that this is going to happen. But the most folks are just like kind of like wait and see attitude, because like like you don't necessarily want the AI agents to work with your data or in your runtime like without like the right guardrails. Generally speaking, like we consider like AI agents like a special type of software system that can perceive and reason and do some steps in autonomy, which kind of like makes agents different than just like copy and pasting things in ChatGPT. It's more like a system that will have to have access to your data systems to do a bunch of stuff and plan a multi-step reasoning, and then do something with minimal or, in our wildest dreams, even no supervision for certain pieces of their workflows, at the very least. So typically, an AI agent will look like something like this. In the specific use case of data, you can imagine, a human interacting with a data system and asking, for instance, questions that are meaningful for the business. Like how many refunds did we give out last year due to delivery problems? And what we expect the agent to do is basically take this request, reason about it, break it down into a bunch of steps, and then interact with the data system that is below. Like, where is the data that is needed to answer this question? It's not necessarily obvious. It depends on a number of things and how you architected your data platforms, how your data platform exposes this information to the agent, and so on. And then you then send basically the agent into this quest in this loop where it reasons, it does something, it reasons again, it tries something. Does that look like the kind of answer that the user is looking for? Yes, then it comes back. No, it goes back into the loop and tries again and tries again and tries again. So it's like an AI agent is essentially a while loop with a lot of intelligence that is externalized to API calls, and it needs to interact with systems where it can fetch the data, right? So historically, you get like, AI systems being fed with data. So, like good old data-centric AI, as like Andrew Yang and Chris Ray. So the better your data, the better your AI system. And now you get like for the first time also kind of like the reverse, where you start seeing, well, I can actually use AI now to interact with my data and help me automate a bunch of operations that I usually do to make sure that the data is fresh, reliable, and trustworthy for the AI to work. So now it's becoming like, for the first time in history, kind of like a loop where you use AI to prepare the data, and then you use the data to make your AI better, and so on. The final use case that I see ultimately is always the same. Like, it doesn't matter, like my experience, 95% of the problems that people have with data is about how do I get good ROI out of my data? And that boils down to how you make sure that people can access and do make actionable decisions or build actionable features that matter to the business, like using the data, right? So for instance, like right now, you see that AI and like more flexible, intelligent interfaces are used in domains like business intelligence. This is a screenshot from like one of the most famous BI tools out there. We're essentially saying, well, I can use an AI system now to have an intelligent co-pilot for a person who might or might not be technical, might or might not be familiar with the data stack, but certainly is familiar with the business problems. It can be an exec, it can be a person who's building the product feature, it can be an analyst. And we just like disintermediate the relationship between the data and the business persona using an AI system, which is fantastic. And compared to the previous world where you have like a dashboard, and the dashboard is fixed, and now I have to go and ask for the dashboard, and the dashboard is done by an analyst, and the analyst needs to ask a data engineer who needs to prepare the data. So it's a long kind of like food chain to get to the final thing that is consumable. This is great. So I can actually just like go and get like an AI agent to do it for me. Problem is that even though this last mile is so actionable, is so interesting, and ultimately is what you want to do, it remains something that is built on top of a bunch of other stuff, like how do we know if the numbers that the AI agent retrieved are right? What queries were run in the background? Is the data fresh? Is that right? How can I even know if I'm not familiar with the data stack and I am a non-technical person and I'm just trusting the AI, basically? And the problem is that even though the interface becomes like fundamentally different, and that is like it is obviously very interesting and obviously like incredible, because now the interface becomes intelligent and not just like a touch point where I consume the data passively. But it remains also fundamentally true that to have that interface, we need to take care of our data in the background. It remains true what it was unfortunately true a while ago, and it's always been true that 85% of your projects will fail because your data suck, and that's it. It's like you cannot really trust them. You cannot really trust it. You don't know like how reliable or fresh or trustworthy the process to generate the data that you rely upon is. So basically what I'm saying is that your intelligent interface, which once again, it's not only a matter of helping you ask a question to your data in English rather than doing SQL. It's much more than that. It's actually bringing intelligence. So it can help me reason through a business problem in a data-driven way, which is really fantastic. Like that ultimate goal sits on the shoulders of boring data engineering. So you still need your pipelines. You still need to have semantic models, data contracts, governance, and policies that you want to be in place. And you still want those things to sit on top of even more fundamental operations like ingestions, transformations, data quality tests, ACID transactions. So like make sure that your data stack is reliable, is repeatable, is a solid foundation for your tip of the iceberg. What you see as your final use case is just one single thing of a gigantic part of, which is essentially your data stack, your data platform, which remains pretty hard to do. So the argument that we want to make today is that your AI will become incredibly valuable in creating intelligent data access to your business personas. And at the same time, that very same AI will play a role in the less visible but fundamental part of building your data ops. And I consider data ops pretty much everything you need to do to make your data reliable, fresh, and trustworthy. So all the work that today is done by a data engineering team or a data platform team can benefit from a type of automation that is also intelligent. And so the vision that we have is that your AI agents will not only help the business persona, but they're going to span throughout the entire life cycle of your data. The problem with data engineering, so the bulk, the submerged part of the iceberg, right, is that data engineering is also the hardest piece and usually where companies will invest more money and where it's harder to see clear ROI. Data is hard because it's volatile. There's constant schema changing. There's a lot of work that your data engineers will do around fixing systems that break because some external system changes. There's a lot of stack fragmentation, which is, basically what today describes most of the stacks out there, with the exception of some end-to-end platforms like Databricks being one of them. But like a data engineer needs to today reason throughout a pretty fragmented and stateful system, which I think is the reason why tools like Cursor or Windsurf or Augment, like tools that are really helpful in writing code, hasn't been super helpful in data engineering just yet. Because the problem there is not really writing code is rarely the bottleneck. The problem here is that like data engineering looks more like DevOps than software engineering and writing code. Go ahead, Lisa.
Yeah, I didn't want to interrupt you, so you are on
You go
an
ahead
amazing
anytime.
line of thought, but there's something that you keep harking on that I think is really interesting here, and that's that in every single diagram that you have, the user is directly interfacing with the agent, right? And this feels very different from traditional applications where a user would make a request, a predictable request, and we would be able to then, on the server side, handle that logic however you want. But it seems now, from what you're saying, the agent actually is able to directly access those systems. So we're not involved in that process. And so it seems now that this data engineering work, all of this ops work, is actually more important than ever, because it seems like the only thing that we actually can control in terms of the behavior and how we actually create those safeguards and things like that. Is that a correct assumption?
I think that workflow is like still very much being designed, but it becomes a matter of understanding. You definitely want to have a workflow where the agent is autonomous to do certain things, because that's really the benefit that the agent brings. And you want to have checkpoints and guardrails where you always want your data engineer to be involved. And like a lot of your success in bringing AI in your data ops will ultimately boil down to how you engineer this kind of like agent-human relationship. Some things like like your typical relationship in your like your typical relation between the teams that touch the data today looks something like this. You have like data engineers, and then you have like more specialized data professionals like data scientists or ML engineers and so on. And then you have other folks who are involved in the data life cycle. They are less core in the data ops, but they are ultimately the closer to the business problem. And you keep engineering your relationships between these guys, which is a lot of in my experience, that's like a lot of work. Like it's an insane amount of work, and it's insane amount of weeks waiting for like tickets to be picked up. Like Jira tickets like sitting there, people getting angry, and like friction between teams. Like it's hard work, and it's a lot of culture and just like designing the taxonomy. And what we think here is, what if the agents become more specialized in taking care of certain specific things? My data practitioner can become a bit more wider in that sense. So like the expertise of the data practitioner can be more like not necessarily super specialized on a single thing. Today you have people that are just like, oh, I'm great at Spark clusters. And then there's another guy who's like, oh, I'm great at like training models. And they're just like very niche skill sets. And you want to have like, to lower the bar, you want to have like a data practitioner that's kind of like wider. And for certain specific things can rely upon the fact that the agent can help. And your job changes pretty radically at that point. Instead of being like the person who goes spelunking into, a certain job or a certain Spark cluster or a certain super niche problem that you take care of, you kind of like orchestrate the swarm of agents that help you out. But the problem there is like, when do you touch point with, like, when do you touch base with the agent? It's like, you don't want the agent to go and just like go, just like, do something and come back 3 days later, who knows with what. I think like a lot of your success will boil down to this, like set goals and policy, it's a human thing. Review plan, approve plan of action, it's a human thing. Decide whether to release, deploy, or to roll back, definitely a human thing. Update your policies and your priority based on what happens, definitely a human thing. You want the agent to be monitor the system, detect the issue, do a root cause analysis initially, try to fix something. The part that can be automated must be the less consequential in terms of the impact that this can have with your business and your practice. Does that answer the question?
Yeah, so looking at this diagram and looking at the sort of flow that you have here, it's very helpful. How does somebody who's really looking to implement agents in their workflow, how do they scope appropriately, right? It's very tempting to let an agent do everything, like you said, and I'm sure that at least for me as a data engineer, I would love that. But it's very hard for me to decide what is the right size of task to try and test with, to try and implement with.
So I think like the mental model that we're developing at Bauplan at least is to start with some fundamental problems that, if not addressed correctly, can be catastrophic. And it sounds like a bit like, I don't want to like sound kind of like alarmist or anything, but that is really like the main friction that we see to adoption. you want to make sure that things like don't go bananas. So I can skip like a couple of slides here because like it's just like easier to see. But like the main problem is even before deciding what in your workflow is the right touch point for an agent and a human, you want to make sure at the very least that two things are true. The agent cannot screw up your runtime. So it cannot install malicious packages. It cannot run code that can be dangerous. So you want to air gap that. And you want to make sure that the agent does not something terrible to your data. That's the bottom line. So you don't want the agent to go just like, hey, here's your production data and this is your production environment. Write some code and run it. Because you will have basically, those horror stories that people, post on X when, with cursor. And you go like, oh, I vibe coded an app, and then all of a sudden, like this thing kind of like went bananas. That is slightly problematic when you vibe code an app. It is catastrophic if you do that on your data lake. So imagine that you're like, like your agent now drops like tables with PII or just like leaks information. It's like, so you want to basically create like as many sandboxes as you can there, and you want to harmonize that. That's the very first, like the mental model that we're adopting is this. Like the very first thing is something like that.
And so can you define sandboxing a little bit in terms of how a data engineer with all these stateful applications, all these databases would appropriately sandbox versus like a traditional application?
Right. So in that case, like, so in that case, I think like the Lakehouse design is particularly well suited. You basically want to do something like this, right? Like you want to diminish the fragmentation because like it's easier to sandbox a single thing rather than many, right? And it's easier to keep control over what the agent does if your system is somehow vertically integrated with your data, right? And the good thing is that the Lakehouse design now provides one solid foundation for your storage. So you can dump stuff in object storage. And you do have the possibility to version your data using open table formats. So the first advice that I would give is think of versioning of your data as your tables. Think of two things. Think of centralizing data in one place as the first thing, because it simplifies a lot. And then versioning must be really a first-class citizen, because that brings the foundation for you to then create like some kind of Git like semantics over your data, so you can create sandboxes of your data without copying the data over and over again. The cool thing about open table formats is that you can do zero copies, right? You can do copies that are very efficient in terms of both performances and costs. So you want to have that kind of foundation. And then the other piece, which I think like the industry right now is thinking more about that rather than the data. I think the data is still fairly new, is your sandboxing needs, like your runtime needs to be sandboxed. Like whatever process runs the agent needs to be air gapped from the host, because that is a place where the agent can go on the internet and download a package. And that's what you don't want to do. So the way we are, there are several ways to implement this, of course, but like the way we are thinking about this is your runtime can be a function, like to have a mental model, something like a Lambda. So basically like a containerized function that is separated from the host and separated from any other process. So your pipelines become a bunch of like functions that are completely isolated. And your data is always a zero copy of some kind of data that is in a open table format. So if you do these two things, worst case, like even if the agent goes absolutely, rogue, basically, what can happen? Like worst case scenario, you have a branch of your data and your runtime where the agent did something profoundly idiotic, and you go, okay, that's fine. I can just like roll back and delete the branch.
That's awesome. So for the audience, none of those questions were planned. I just keep throwing Ciro all of these like hard balls, and he keeps knocking them out of the park. So thank you so much. I'll let you get back to the presentation, but we definitely look forward to asking more questions to you later.
I think like honestly, like the presentation is kind of over. If you want to, I can show you what this looks like in real life, because like the last point that I want to make, so wrapping up, is it's really important that the data ops piece is addressed in this quest of using intelligent systems to democratize data access, which is ultimately the goal. Like ultimately, you want to have good ROI for your data, and that boils down always, with no exception, to somebody who is building something that is meaningful to your business, being able to use the data. And using AI is fantastic because like now I have intelligence in it. The problem is that that thing sits on top of boring stuff that somebody needs to take care of. And the good thing is that the same AI that we can use there to help the final business user can be used to automate a lot of the boring stuff and do way more than with less. To do that, there's a number of things you want to take care of. And as I said, I think the workflow is still very much in the making. I don't think anybody has figured it out yet. We don't know exactly what it's going to look like. But one thing for sure, you want to make sure that the agent is always able to be air gapped, and you are always able to audit exactly what the agent did and to roll back. So the agent needs to be isolated. You need to be able to have like a very clear way to audit what the agent does. And in the most catastrophic scenario, you just travel back in time like nothing happened. That would be like my general recipe for thinking about bringing agents in your data ops, in your data platform. But Jacopo can show you what it looks like if you want. I don't know what time.
So
how
very, I think we're good for time so far, but we do have a very related question just before you move on to your hands-on component from Peter in the chat, saying, how about an agent that knows what/how to sandbox? So can we get even more meta with this? And have you seen anything like that? That like an agent that maybe maintains some sort of container for you, or that writes these sort of configurations even?
So when there's the distinction between running an agent like in the platform, like running a pipeline in the sense, which is what we're gonna see, and then running a meta sort of an agent at the meta layer when you decide what to run. And then when you run it in the pipeline, the system, Bauplan specifically, is declarative in the sense that the agent or any human cannot really decide how packages are installed or how data is accessed, and that's the virtue of the system. You just say what data you want and what packages you want, and it's the underlying system that makes them available. That's true for human or for agent. It turns out to be a good decision in both cases, but that was the original idea. And in fact, our functions don't need internet access because the data is completely provided to them by the underlying system, and the function doesn't know anything about the surrounding of it. So there's no need for explicit, let's say, awareness of the sandboxing aspect, because sandboxing sort of is the default. Actually, it's the only choice that you can make. There's not such thing that you cannot run anything that is not sandbox or branch in Bauplan, even if you want to. And again, there was a design decision that kind of predates this whole movement. It turns out to be just a very good decisions. We were at the LDB a couple of weeks ago, the database conference. There was like Mattei was discussing agents on data stuff, and it was like an agent is kind of a caffeinated intern. That's what that was his way of thinking about this. And so our side is like, well, our platform was built for it to be so easy the intern can use it, and so agents can naturally use it in the same meaningful sense. I think that's a very good mental model of like how things work. If you can make it so that an intern cannot mess things up, an agent will be fine in the same sense.
Amazing. Thank you so much. All right, let's get on to this hands-on demo component that I know that you've prepared.
Do you want to? Yeah, so you can probably see you see my screen?
Yes.
So I mean, this is the kind of like a standard, Bauplan page. I just show you basically the job that will run, in this case by Jacopo, by me. This is our public sandbox. By the way, you can try it out for free. You can just sign up at bauplanlabs.com. But what we want to show you now, and it's fun because it's going to be a live demo with a non-deterministic component, with an LLM. Everybody knows that you should never do live demo, even with your own software. But now we're going to do a live demo with non-deterministic software, so it's going to be even more fun. But what we're showing here is like, imagine me as a data person, right? Data engineer, just data scientist. I do a lot of pipelines. I schedule some of the pipelines. I wake up in the morning, I open my Bauplan account, and it's like, oh, there's some failure there, okay? And then, of course, in the old world, option one, I will go inside each one of this, and I will go and retrieve the project, and I will try and figure out what's wrong. And there's nothing bad with it, except for the fact that, as Chiro mentioned, 80% of the time that my company pays me for is about basically babysitting, things that keeps on failing and errors in the data, in the packages, and so on. So that's all good and well, but we know what to do. And today we want to see the new world, like, the brave new world in which I wake up in the morning, I see the pipelines are failing, but I want to somehow turn to our AI overlords for some help in actually debugging this. And so we're going to now see live how to do that by using the same architecture that Chiro presented. So I'm going to use a terminal interface. I'm going to use Claude Code. You can use whatever you want. Doesn't really matter. And then we're going to use the Bauplan MCP server, which is going to be the connection between the reasoning of the agent and the Bauplan Lakehouse built on open formats. Going back to Lisa's previous point, we're kind of cutting all the man in the middle, in the sense that the interaction between me and the Lakehouse is going to be literally text, as we're going to see, and it's going to be basically unfiltered. That's why it's so important to have guardrails to not mess things up, because there's literally no filter between my English and what's happening, if not for the MCP server that translates this to API. So let me show you I think I need to, however, show you my terminal, and it's going to be like this. So this is my Visual Studio. Hope you see that. I put it a bit larger. So this is a standard Bauplan project. Doesn't really matter what it does in this specific moment. It's just a pipeline, right? So there's a couple of functions, as we discussed. Bauplan pipelines are simple Python functions. We're using the taxi data set. We're using some decorator to express in a declarative way the packages that we need. You see here. And there's some pandas logic that does, some transformation that we want to run, okay? And so I wake up, remember, I have two failures. I want to use an LLM to debug it. Let's see how we can do it. So I'm just going to ask Claude Code. This is Claude Code. Again, you can have it yourself to use the Bauplan MCP and retrieve the failed job in my last hour. Okay. And so once I press enter, the system starts reasoning about it and is like, okay, I can call the MCP, I can get the job with status SQL fail, and then I'm gonna let you know which jobs that I actually find out that are wrong, okay? And remember, it needs to be at least a couple of them. So let's see if Claude doesn't fail on live. Okay, awesome, okay. So very good. It's like, okay, these are the recent one, which is, the one that we saw, and it's like, and there's a bunch of them, like, what you would like to do. And what we want to do is like, can you help me figure out what's wrong? Okay, so for the two most recent ones, can you please use the logs and the code to figure out what was wrong and tell me the root cause of the failure? Again, there's no filter. I'm just literally telling the agent what to do. The agent is gonna go in the underlying system. You see here, you see all the calls to the MCP server. The system understands. The MCP server is so trivial that it's very easy to understand. Remember the inter metaphor. We're gonna get the job details. The job details gonna go into the agent. The agent gonna start reasoning about the system. And we're gonna see here the powerful of having this vertically integrated system, functions, data, all in one, because the system can literally automatically do that. In a few seconds, we figured out that the first problem was a code problem. In this case, you see here, actually you can see here. If you know the taxi data set, that's a misspell of a column. So basically this is a typo. So, like it happens a million times in SQL and Python, you just misspell a column. And so this is why this thing was wrong. And this is a more subtle one, right? So there's another error, which is about package compatibility. We have pandas 2.0, but the release of NumPy basically screw up the container. So the container could not be built and the system figured it out. So in 10 seconds, we have the two diagnoses of what went wrong. And of course, what's the next thing that we can do? Well, let's fix it, right? Thank you. Thank you. Can you modify yourself to fix those issues? Run the pipeline again on a, sorry, it's really hard for me to type when people watch me, even indirectly, I don't know why. on a debug branch and then run the pipeline again to make sure it works. So now what I'm asking the system to do is, okay, can you please just do the code changes yourself if you believe that's a problem, and then can you run it basically on the back branch? I'm gonna allow the edit, and I'm gonna see the system actually making the required change, which is amazing. You're gonna see this in your life. And this is like the escape hatch that Chiro was mentioning, right? We're seeing this thing changes, so I can stop it in any moment in time if I believe the system is doing something that is not correct, okay? I'm gonna give him the ability to check for branches, and then it's gonna say, okay, there's no debug branch. I'm gonna create a debug branch. Again, all of this with minimal instructions, and a branch is a zero copy of our entire lake. It's like Git, but for your data. So now we're running this new pipeline, not on production. We're running this pipeline on a sandbox part of your sandbox. So even if something bad is gonna happen, which I don't think it is because it seems that the code now is correct, this is completely sandbox and won't create any disruption in the downstream system. Running is done. We run all the functions. Let's see to have a confirmation that the job actually status is correct. And once that is done, we can go and check the final result of the system. Okay, so things are run. This is the job that we run. Everything will be on the debug branch. And what I want to do here is I'm gonna do Bauplan branch checkout. I'm gonna actually check the branch that the system just did, and I'm gonna figure out what's in this table. Voila. So in this part of the data branch, as a sandbox, these entire agents recreated the pipeline, build the downstream data model correctly by fixing 2 mistakes in one, and then sends me back the branch in a type of like human in the loop PR type of style, where Jacopo, as a human, can go in, verify that this is correct, verify that the thing actually materializes, and now I can merge it back into the system. So it's kind of like a unified vertical integration of like Git, AI, and normal data engineering, so that my hours of time chasing bugs cuts down to a few minutes of basically interacting with a system that can do most of this by itself.
That is awesome. I have a couple questions, and thank you so much. This is a really cool demo and something that's really straightforward. So anybody who's vibe coded anything knows that if you're doing an application, what sometimes will happen is that AI will just commit these gigantic changes to your code base, and you're just trying to get something to work. And this is something that actually gives you more fine-grained control and more visibility into what changes are actually occurring in terms of statefulness. And so in terms of environment, how large of an environment are you reaching out to with this? And have you tried like other types of data, like streaming data, like multimodal? Like what have you experimented with in terms of scoping this out?
Oh,
yeah. So Bauplan, like bread and butter is like data pipelines, batching or maker batching. So that's our, it's our kind of like, the vast majority of our use cases are into that. And they typically come into flavors, very left, ELT, write or publish type of pattern, which actually is very easy to automate with this kind of reasoning, because at the end of the day, branches are already part of the write or publish pattern thing, and you just basically put them on steroids with the agentic stuff. And then going right or like more right, it's gonna be data and ML AI pipelines of like, I want to call an LLM to reach some data, I want to do some data science, I want to train some models, and then I want to produce a downstream tables to do that. So these are kind of like the two big
they're like use cases are mostly like shift, like for us, like now is mostly like kind of like shift left kind of thing.
Yeah.
Yeah.
So another follow-up question on my end, because Git is very easy, in my opinion, to get started with, but very hard to master.
Yes.
Especially if you're trying to rebase, if you're trying to rewrite histories, if you accidentally committed a secret. And so what are some of the challenges that you had in sort of mitigating some of these behaviors for when you need to actually use Git for what Git is for?
Like that, this is a super interesting question. Like Git, well, first of all, yes, Git was, after all, the version control from hell. That was defined. That was like the first commit for Git was defined like that. So yeah, it's very hard to master. I think like, so there's one thing that is very important for us is the Git for data has been up until now mostly an analogy. So you kind of like, you have this loose concepts in data that map onto Git, and you say like, well, you have a branch for your code, you have a branch also for Git, for your data, and so on. Now, I think like both the fact that Git for data never like is still not a very widespread practice, and the fact that the number of people, like number of actors that at the same time are going to work on the data is lower than the amount of actors that will at the same time work on a code base, made this analogy go unchallenged for a while. So it's fine if it is an analogy. Now it's like with the AI agents, it's not necessarily the case anymore. So if I have to build towards a future that I think is plausible, there's going to be hundreds of, like for each data team, there's going to be hundreds of agents that kind of like do stuff at the same time. Because that's really what automation is about. It's just like, it's a robot. So having like a very good formal model of what Git for data means is an active area of development for us. And it's pretty unique. Like it's an uncharted territory.
Yeah, I love that you mentioned that, because I think I've seen a lot of patterns try and emerge throughout the years that are very tool specific, but also can be hard to adopt, right? Like write, audit, publish comes to mind, like CDC, or even like CDF, like change data feeds.
Yeah.
And there's always a difficulty there of understanding the diff between databases. And so, how do you merge these things? And how have you taken those sort of patterns as these learnings as you're refining this tool?
But even just like predicting what is the, so there are like certain concepts that like it's not necessarily clear how you translate, right? Like what is rebase for data, right? Or the other thing is, when we like, can we deterministically predict what is this the state in which a system will be in a certain scenario? And if you look at what Git for data looks like today in a commercial offering, well, the answer is no. Like the answer is just no. And like, so, which was true for Git as well, by the way. Like Git has been, like the Git that we use for code has been weirdly non-deterministic for a long time. Like people use that in a way that wasn't formally proved for like a long time. But I think like the more we go towards a world where like automation will create like the swarm of little agents doing things together, what we are specifically doing, like we're working a lot on formal proofing. So we want to make like, we have like ways to predict what the stages of the system will be without having to actually do it, but like go through a formal proof, which cuts your space of possibilities by orders of magnitude, and we know deterministically what is going to happen.
That is really exciting. And I'm excited to have you back on again once that work starts moving along and we see this in like these giant enterprise systems, and you've had to work on this a little bit more. There's a very important question in the chat that I need to make sure gets answered 100% before we leave. Peter has asked, if you don't say thank you, does the AI mind?
That's a good point. Like I think I'm a boomer, so I still interact with this thing like a human. But I think yes, I think you can probably drop the thank you and the insults. Sometimes at least me, when the system doesn't do what you want, you really try not to be very very direct about it. But yes, but I think
that's why it's so important to sandbox the AI, because like even if it gets angry at you because you're rude, it cannot drop your tables, right? Like it cannot really, do you harm.
Have you guys had to integrate any sort of like sensitive workflows or encrypted workflows, like places where you really don't want a human in there, but you still need to transform or work with the data in some sort of way?
So all our platforms work in single tenant isolation, and the buckets, like the data is always on our customer like bucket. So whatever level of security they want for the data, so they want encryption at rest, and then there's gonna be some key somewhere that only the runners, only the actual function can access inside. That's totally supported by the platform. Our platform does never see the data per se, because we operate at the control level, and then the workers can be in our managed system or in customer system, but they're all single tenant privately linked with the actual data. So we actually have no idea what goes on in the data part of the transformation.
Well, especially because like our customers tend to be like financial services, like they easily go into realms where this is important. So we have like a few customers that do like we certainly have a big customer that processes like an insane amount of PII in Europe. And we have like some financial services related companies that use the platform today. So even if they're operating like a smaller scale, they're still very protective for regulatory reasons.
But to be very clear, agents, like the entire platform access through API, and agents are users which identity and roles can be scoped down like you would guess that it is, right? So you can have a user like Jacopo, which now is acting with Cloud Code using an API key that pertains to an agent that will, like they're being scoped down to just, I don't know, be read-only or, for example, or just, like write some tables or whatnot. So like it goes like agents are at the end of the day, again, just interns. So you can just scope down their privileges to make them harmless. But I think the point of this entire presentation is that it doesn't matter how harmless you make, to be useful, they need to be able to do something. Otherwise, you could just read stuff. Like, again, at the end of the day, the difference between reading and like actual data engineering is useful because you write stuff. And so they need to write something. And as we always say, writes in Bauplan are immutable, but never fatal, right? So every write is always be there. So you can never, there's always auditable, but the error is always recoverable because of this entire branching and committing and rollback type of thing. So you kind of have, we think we have the both of both words. You can do stuff, move fast, but don't break things. You can always go back.
Love it. And I think that was an amazing answer for us to begin wrapping up on. So we did do a poll earlier asking folks how they were using agents right now. And I want to share the results. And I want Ciro and Jacopo to comment how they're using agents and to provide any closing remarks in terms of how they're seeing agents being used out in the wild, how they're using agents, how they see agents in the future.
I think like this matches, like this poll like matches my experience a lot. Like writing code, 100% like what people do today. Data engineering is more ops heavy than just writing code. The bottleneck is rarely writing the code. The bottleneck is orchestrating and figuring out how to operate like a fragmented stateful system. I think like the next phase of the adoption for agents will be systems like that. So DataOps is one case. We focus on that specifically, but DevOps in general, I think, is an area that is up to fantastic disruption thanks to agent, because like it really brings like a kind of automation that we never thought possible, right? Like it's intelligent, like it's more flexible than what we believed it was before. Interface with my data. See, I told you, the only thing that matters is that you can chat with your data. Another question is like, are you chatting with data you can trust? Yes or no? That's the point.
Awesome. And so what is maybe the number one way that you guys are using agents that are outside of the data realm? I'm very curious to hear that as well.
We now in our like working life, like outside of Bauplan, all of our team use Cloud Code, like use basically agents to help us with coding and especially writing that, do the boring stuff you don't want to do with coding. So all the team now is kind of like ramp up into this flow of doing that. Now for me, it's kind of like the by far the biggest use case. The other thing is that for, at least for me, for English grammar correction when I need to do a LinkedIn post. So yes, I find that's my very specific niche use case of like, can you check that is correct? And that's it.
Awesome. And if people don't want to interface with agents, but they want to talk to you guys directly, how can they find you and where would you like to direct them if they're more interested in Bauplan?
So you can go on bauplanlabs.com. If you want to take a look at the platform, we have a public sandbox that developers can sign up and try the platform. We are reachable mostly on LinkedIn and via email. We're super happy to chat. We also are presenting a lot around, like we work a lot with especially like kind of like Python and Iceberg community. So reach out. We're very easy to find and to reach out to. The hub is bauplanlabs.com.
Awesome. Well, thank you so much for joining us. I know that there are some leftover questions. Please feel free to ask them online or in the chat, as well as you reach out to them on LinkedIn. They're very public. They're very out there. They're very knowledgeable as well. Thank you so much for all the interest, and thank you for sharing your knowledge today, Ciro and Jacobo.
Thank you very much.
Thanks for having us.
It's been a lot of fun.
Everybody else
Thank you.
for tuning in.
Bye.